Hello everyone, welcome back to the channel. I hope you guys are doing pretty well. So we will see today's daily challenge on Leetcode and we will also try to solve it together. So yeah, today's challenge is definitely a little bit difficult. So yeah, but if you think it in the right direction, it will be easy for you. Okay, so please focus. So we have this question: find all possible stable binary arrays. So you are given three positive integers, 0, 1, and limit. A binary array is called stable if the number of occurrences of 0 in array is exactly 0, number of occurrences of 1 is exactly only 1, and each subarray of array which is size greater than limit must contain both zeros and 1. So what do you mean by this is that with a size greater than limit must contain both zeros and 1. So you need to prevent something from happening, that which is a consecutive number of zeros or ones should not in limit plus 1 should not be present. Okay, a consecutive number of zeros and ones. So return the total number of stable binary arrays, and if the answer may be very large, return it modulo 1 plus 7. So if you try to understand this question with this example number 3, you need to construct an array which has three zeros on also has three ones, but limit is 2. It means that no array, no subarray of a size greater than limit should contain consecutive zeros or consecutive ones. Okay, so it means that there should not be three ones consecutive or three zeros consecutive. Okay, limit plus 1. So you see, in all the examples which are shown here, you can no matter which subarray you take, you will never get 1 1 1 or 0 0 0 like this. Okay, because the consecutive things we are trying to prevent. So yeah, this question which says that each subarray of array which is size greater than limit must contain both zeros and ones, it is equivalent to saying that each subarray, so it is equivalent, the problem statement can be said that it is equivalent to saying that each subarray of size limit plus 1, at least limit plus 1, okay, should not have consecutive, should not have all zeros or ones, all zeros or ones. So each subarray of size this should not have all zeros or ones. You just need to prevent this from happening, and that's how your condition will be fulfilled. Okay, I hope you at least understood the problem statement very clearly, and I hope you will definitely try this problem on your own before moving it to the solution. Okay, so let's see. So now, if you will read this problem, you might think that it is a combinatorial problem. And whenever you get any combinatorial problem and it is getting very difficult to solve, you can also solve it using DP. Okay, and you can should at least give a try for that. And you see, let's try to see what is happening here. So you need to construct an array. So you are told that you will be given ones number of variables. So you need to use ones one and zeros. These two variables you are given, and you are also given a limit, uh, which you should prevent this thing from happening. Okay, whichever I told. So how can you start constructing the array? You can start with a 0, and you can try to append a 0 to this. You will get this array, and if you try to append a 1 from this. Okay, so there are two choices. If you append a 0, you can append a 1. Then again at this choice, you have again two choices. You can append a 0, okay, and you can also append a 1. Similarly, you can get all possible arrays from this uh, idea, right? 0 1 1. So given, then definitely if you are trying to add a 0, you need to see that, hey, whether my zeros is present or not. So if zeros is only 2, you cannot add the third 0, right? So you, this case will not be possible in that case. Okay, yeah, but I hope you do get the idea. And not only starting with zeros, an array can also be there which starts with 1. Okay, and you can maybe choose to append 0 or 1 to this, so you will get some things like this. Okay, and so on. So definitely it gives you an idea that, hey, there are two choices for this. Whatever you are doing, there are two choices in each state, okay, and therefore we can try to think of something DP here. Okay, and this is, I hope it is a take not take or 0 1 kind of DP. Place a 0 or place a 1 when you have, whenever you have choices to place. Okay, then you do try recursion and memoization and DP stuffs like that. Okay, So from this you get the idea that hey, definitely we should give a shot at DP. So we will try to understand in detail what is happening here, and yeah, why exactly, how exactly can we do this. So now the thing which comes to your mind is that there can be two possible DP, right? See, once that starts with 0, once that starts with 1, it is also same as telling that the last element is 0 or 1. Okay, so you can create one DP as DP0 ij. Okay, something like that. So this DP will tell you something like there should be I zeros in the string which you have formed, there should be j ones in the string which you have formed, and also that should end with 0. Why end with 0? Because you see, ending with 0 or 1 creates a unique state, because initially you had 1 0 or 1, so that's ending with 0 and 1, and then when you are appending a 0 and appending a 1 to it also, that's ending with 0 or 1, so it creates a unique state which you can define it in the DP. Okay, and DP of 1 ij, it simply means that there is again I zeros and there is again j ones, but they end with 1. Okay, they end with 1. Now again, that if you try to think the repeat transition, that hey, and at the end what you can do, you can just give dp0. So you have this variable 0 and 1, right? 0 and 1, you have these two named variable, so total zeros and total ones, starting with this configuration, you can just calculate, plus starting with 1, total zeros and total 1, whichever is there, this will be our final answer. Okay, okay, final answer. Okay, and now the dpij, if you're thinking, hey, how I will get something like this, how I will calculate this, then this is also very easy if you try to think, because you want a series. This tells you that you have a series which ends with 0. Okay, which ends with 0. And you need to follow this. Okay, you need to make sure that it does not violate this. Okay, should not have all zeros and ones, all the sub arrays of limit. Okay, and how will you do this? You can say that I am having here I zeros and j ones. Okay, so the state from previously can be something like this. So let's say it can be derived from I minus 1 zeros. Why? Because you have I minus 1 zeros and you are appending 1 0. So in our whole simulation, we are appending a 0 or 1, right? So from I minus 1 zeros, I minus 1 zeros, if you append 1 0, it will become I zeros, right? Quite obviously. And j1 number of ones is fixed, because you are not appending any one from this. So in order to calculate this state of DP, you can use this state definitely. And even if your DP ends with 1, it doesn't matter. I minus 1 j. It means that your DP, this denotes something like this was ending with 1, something like this was ending with 0. Okay, and you are trying to append another 0 over here, and you are trying to append another 1 over here, and you have a till this portion, you are having I minus 1 zeros, and here also till this portion you are having I minus 1 zeros. So there is no problem. If you append 1 zeros, there will be total of I zeros, and j ones is already there. J ones is already there. Okay, so that's what. But see, this make violate some criteria, right? What was our criteria? There should not be a subarray of size limit plus 1 should not have all zeros or ones. Okay, so uh, should not have all zeros or ones. So how will you deal with that? Okay, how will you deal with that exactly? So should not have all. So if you see, if there are limit number of zeros over here, if there are limit number of zeros over here, okay, and you are trying to add another 0, which will make limit plus 1 consecutive zeros. But in this case, even if you have in between, if you have some limit number of zeros, and if you are adding a 0 over here, this will not create any because see, those set of zeros are isolated from this, so they are not continuous. Okay, so they are not continuous, but it may happen that there are limit number of zeros already over here, and you are adding one extra 0 to make it, so to violate the criteria. Okay, to violate the criteria, but there may be some one also present. So there may or may not be happening. Okay, so there will be some cases that must happen like this. So you want to prevent those cases from happening, right? So you want to prevent the cases which have, let's say, uh, limit zeros over here. Okay, let's say at the end only there are limit zeros, and you are trying to append another zero, making it limit plus one. Okay, so you want to prevent this from happening. So if there are limit zeros, whenever this just happens, you need to prevent that. So it means that if there are limit zeros, it means that there should have been a one over here. Okay, there should have been a one over here. So do you understand something from this? You need to subtract dp of 1 because it's end with 1, and this is the same as this. How I'm asking that how many times this will occur. So you see how many ways of putting all consecutive zero. There is only one way. So that is equivalent to asking yourself that, see, this is, I am in the dpi, right? This was dpi minus 1, I zeros. So this will be what? Dp I minus limit minus 1. Okay, so dpi minus limit minus 1. Why? Because there are I minus limit minus 1 number of zeros present in there which are consecutive. Okay, and j, once is j. Okay, so this is the thing which you need to subtract. Okay, so what will be your dp transition? The final dp transition, if you try to write it, it will be very simple. You see, dpij will be nothing but, again, to revise it, dp0ij, if I'm talking of, you can derive from 0 I minus 1 j. Again, you can derive from 1 I minus 1 j. Okay, you are placing a 0 from in these things, and you're also subtracting dp1 I minus limit minus 1 and j. Okay, so yeah, I hope it is very clear why I am using dp1, because there are limit consecutive zeros. Okay, and I am trying to place this extra 0 1, so I will get from limit I minus limit minus 1, and dp1 because it ends with 1. Okay, and j. So we have this transition, and again, I hope you can now easily derive this also. I'm not showing that dp I1 ij, it is similar to, very similar to this. So it will be like you are adding from j minus 1. So dp0 I j minus 1. So j minus 1, from j minus 1 1, you are appending another one to make it j ones. Okay, so that's what you are doing here. And dp1 I j minus 1. And so what will you do the subtraction? Again, you do not want to make limit plus 1 consecutive ones also. So you need to have something like this, I and j minus limit minus 1. I hope it is very clear and there should not be any doubt. And yeah, you have the dp transitions ready with you and everything, but you need the base cases also, right? So base cases are very simple actually. So you try to see what will be the base cases. So what if there are all zeros? Okay, okay. So I am telling that there are I zeros and j ones, right? So if you try to think of I equals to 0 or j equals to 0, something like that. So it means that if there are 0 zeros, it means this that all are ones. And if the j is 0, it means that number of 1 is 0. It means that all are zeros. So in this case, there is only one choice for that. Okay, there is only one choice for that. But you must make sure it should not violate the limit criteria. Okay, it should not violate the limit criteria, whatever is there. So if limit says 5, you have to clip the value at 5. So if limit says that 5, you have to clip at 5. Even if, let's say, your number of zeros is something like 6, you cannot place 6 zeros together. The answer for that will be 0. Okay, you cannot place 6 zeros together. But if your I is something like 3, so it tells you that, hey, you can easily place 3 zeros. If your I is something like 4, you can easily place 4 zeros. If your I is something like 5, you can easily place 5 zeros. But if your I is something like 6, you cannot place 6 zeros together. In that case, number of occurrences, number of strings will be 0, Otherwise, there is only one choice of making this, so the answer will be 1 for this. Okay, so you can define your base case very easily like this. And yeah, I hope that will be all. You can just start to code it on your own. Let's see how we'll do this. So first, we will try to have one hash define ll long long. Okay, and uh, let's have a modulo which is nothing but 1e9 plus 7. Okay, why we need long long if we are already doing modulo? But you will understand that anyway, that if we add two integers, we just exceeds the long long value, but those two integers are in the int range only. So you are adding that those and then performing the mod, right? So you need a long long. So we, as we told, that we will have 2 dp. Okay, and yeah, I could have made it into a 3D array and make you more confused, right? But yeah, I will prefer not to do that. And 0 plus 1, and uh, we have vector integer, and we have 1 plus 1, and we will initialize everything with zeros. And yeah, we have, so I will create 2 dp tables with uh, zeros cross ones. Okay, uh, and the base cases, at first you need to fill up the base case. Okay, so as I told you, you need to clip the value at limit. Okay, so if I is 0 or j is 0, you need to fill the base cases. So if let's say, or let's calculate for j 0. Okay, so let's calculate here for j 0. Then we will iterate through all the i's. We can start from making sure that we have 1 0. Okay, but we should go all the way till what? Minimum of 0 and limit. Okay, because we do not want this to exceed the limit. Okay, otherwise if it exceeds, the remaining states of dp are already initialized with 0, so they will be 0 anyways. Okay, so otherwise this dp0 of I0, so it means that at the end, see, dp0, what does this mean? That it ends with 0, right? And only that you need to fill if you have all the zeros. Okay, g equal to 0, meaning that all zeros. Okay, because number of ones is 0, it means that all zeros. So yeah, you can have only one choice, as I told you, only one choice, that is keep all the zeros. So yeah, if limit is exceeding, if zeros is exceeding the limit, then keep the value at limit only. You do not need to fill any further. That's what it is told. And very similarly, you try to write this for I equals to 0. It means that all ones. So again, all ones. How many ways of filling all ones? Definitely again 0 ways. One way. Okay, one way to fill all the ones. And you have, but you need to have your iterating variable as j, and minimum of definitely 1 comma limit. Okay, I hope the base cases are very clear and there should not be any doubt in this. And we have the final loop, which will go from I equals to, let's say, 1 to 0, I plus plus, right? So starting from whether to fill 1 0 or everything, you can go till zeros, and j less than equal to 1, j plus plus. Okay, yeah, uh yeah, you do have this. And let's try to calculate the dp transition. Okay, whatever dp transition I told you. So uh we will have a value, so let's call it long long. Okay, let's call it val 0. Okay, this we are writing the dp transition, right? So dp0, from where do we get dp0 ij? Okay, deriving dp0 ij. So transition for dp0 ij. Okay, so from where do we get I zeros and j ones? We can get it from appending a 0 to I minus 1 zeros, and also appending dp1 I minus 1 j again. Okay, I hope it is very clear and there should be no doubt. And we also want to make this long, right? Yeah, so we want to make this long. Uh, so let's make it long. One of the, if you make long and another is integer, they will add up to give the final long only. I hope you know this. And you see, as I told you, the transition also had this subtraction, right? Yeah, but we also need to make sure that this thing does not becomes less than zero. So dp of this is an ultimately this is an index, right? So we should make sure that it does not go -1. So that's another if criteria we will put. So we'll just tell you that if I minus limit -1 greater than equal to 0. So if this happens to be greater than equal to 0, then definitely you need to subtract this from the dp of 1. And yeah, what was the our equation? dp of 1, I minus limit -1 and j. So I minus limit -1 and j. I hope you are having at least no doubt in this. Okay, there should not be any doubt because yeah, I clearly explained why this is happening. Yeah, and what after this, if you try to see dpij, dp0ij, we can start to fill. Okay, it will be nothing but this value, whatever is contained in this value, 0. But you need to put the mod now. Okay, but you might think that hey, I will just put a mod simply like this, but that will not work because you see there is a subtraction. Now subtraction might make the answer even negative. Okay, if the answers are very large. So what you generally do is also add a mod. So if there is a subtraction, I hope you know how to calculate this mod. Plus mod, whole mod, you do like this. Okay, yeah. So this is nothing but this thing. So if a plus b whole mod, I hope this goes something like this: a mod, a modulo mod plus b modulo mod. Okay, but if you have something like a minus b whole modulo, that is nothing but a plus b plus mod, a minus b plus mod, sorry, a minus b plus mod, okay, whole mod. You need to do it like this. This expands to this. Okay, so yeah, you can, if you did not know this, you can search it on Google also. I hope it is simple only, not very difficult. And again, you have now the transition for dp1 ij, and that will also be very similar to this. So yeah, you can just copy this, yeah, just pasted this. So yeah, and that will be something like val1. uh, how you can derive this equation, you can do ij minus 1. Okay, and this will also be I minus, because from now j minus 1 once you are trying to get j once. Okay, so yeah, if j minus limit this is get true, then val1 should be something like dp0 I and j minus limit -1. Okay, and you have dp of 1 ij filled now. Okay, filled with this value 1. And yeah, that's all. Just you can, at the end you can just return your answer. So after these two for loops, uh, at the end you can just simply return uh, let's say long of dp0 ij. Okay, not ij, obviously this will be uh, 0 and 1. So you are using all zeros and ones, but starting with 0. Okay, and you are also taking the case of starting with 1, and you are using all the zeros given to you and all the ones given to you. And at the end also, definitely you want to perform a mod. So uh, you have this modulo also. So yeah, that's all, I guess. If you try to run this and check if there is any error we did, or it just works fine. Yeah, so we are getting a wrong answer. So let's try to debug where exactly we went wrong. And let's see the whole thing again. So you have a modulo and a dp 0 plus 1, 1 plus 1. You initialize both of them with zeros, and you have an int 1, I less than equal to minimum of 0 limit I plus plus. Uh, you initialize all those to ones. That is perfectly all right. And this is minimum of 1 comma limit j plus plus and dp is 0. Okay, so you have this 1, right? This is 0, this should be 1. Let's try to run it now and see if this was only the error. Yeah, let's try to submit it for all cases. So you see it works perfectly fine, and also it gives a decent runtime and memory complexity. And I hope there was no problem in understanding this whole solution. And if you see, this is nothing but find all possible stable binary arrays 1. Okay. So if you try to see, let's see what is the tools, because we have already, what is the time complexity? You see, we have already solved it in ones into zeros time complexity. Okay, we have not used much, only n square type of thing we have used. So if you see the next problem, this is a hard problem. It has exactly the same thing, and constraint are 1,000, and since we are solving it in zeros into ones limit, do you think we will also be able to solve this if we just copy paste this? Let's try to check. Or it does give you a TLE. So yeah, it also works on this hard problem, and the because the time complexity is very simple, it is just a simple 2D DP table which we are creating two times. So it will be ones into zeros only. Okay, so yeah, that's all for this problem, I guess. And yeah, I will meet you in the next video. If you have any doubt, you can definitely ask me in the comment section. uh, Till then, thanks a lot.